Power in AC circuits. For the average power in an AC circuit, we define theta equals to the absolute value of theta V minus theta I, which is the phase angle between the voltage and current, and the average power is then given by the product of the amplitude of voltage and current divided by 2 times by the cosine of theta. The term cosine of theta, which controls the average power flow, is called the power factor. In a purely resistive circuit, since the voltage and current are in phase, the theta value is just 0, and cos of 0 gives a power factor of 1. In a purely inductive circuit, since the voltage leads the current by 90 degrees, the theta value is 90, and cos of 90 gives a power factor of 0. In a purely capacitive circuit, since the current leads the voltage by 90 degrees, again the power factor is given by cos of 90 and is equal to 0. The average power dissipated by an ideal capacitor or inductor is 0 watts. The power factor, often denoted F subscript P, can be found using the average power divided by the product of the RMS voltage and current. The power factor is given the term either leading or lagging, based upon the current through the load. If the current leads the voltage, then it's a leading power factor, and if it lags the voltage, then it's a lagging power factor. Capacitive circuits are leading and inductive lagging. True, reactive, and apparent power. P is defined as the true power, the actual power being used or dissipated by resistive elements in a circuit. It's given by the current squared times by the resistance. Q equals the reactive power, imaginary power from reactive elements, capacitor and inductor, which draw current and drop voltage but don't dissipate like a resistor. It's given by the current squared times by the reactance. S is equal to the apparent power, a combination of the true and reactive power. The power triangle relates apparent power to true and reactive power. Using trigonometry, we can find the apparent power from the reactive and true power. The power factor is the ratio of the true real power that is used to do work and the apparent power that is supplied to the circuit. Values range from 0 to 1. A higher power factor is desirable as it minimizes the amount of reactive power needed by the load, reducing heat losses and maximizing efficiency. Now for a simple question involving the power factor. To find the power factor, we simply take the cosine of the phase angle between the voltage and current. This is found using the absolute value of theta V minus theta I. To find the average power, it's just the product of the amplitude of voltage and current divided by 2 times by the power factor. This gives our final answers.